All right, we're going to take a look at the following problem here. They give you x squared plus 4x squared over x plus 2 quantity squared equals 5. They want you to solve for x here. So first thing you want to do here is if you want to tackle this direct method, we can go ahead and multiply across by the denominator, giving us the following. X squared times x plus 2 quantity squared plus just the 4x squared is 5 times x plus 2 squared. Again, the plan of attack here is let's expand it all out and see if we can actually find roots of this polynomial. So I'm going to go ahead and expand this out here, to which we're going to get here x squared plus 4x plus 4. And then we have our 4x squared, and expanding out this x squared plus 4x plus 4. Then distribute, we get x to the fourth plus 4x cubed plus 4x squared plus another 4x squared, and we get 5x squared plus 20x plus 20. So I'm going to go ahead and clean things up where I can. You can see here I have like terms on the left-hand side. I'll do those first here, and this will simplify to become x to the fourth plus 4x cubed plus 8x squared equals 5x squared plus 20x plus 20. Bring everything to one side here. We now have x to the fourth plus 4x cubed plus 3x squared minus 20x minus 20 equals 0. All right, so this method, while straightforward, does not always work. We're hoping that in this situation here, hoping to get ourselves in a situation where this polynomial has a rational root. So I know by the rational root test, if this polynomial does have a rational root, it'll be a factor of this negative 20. So if you write down the factors of negative 20, we have what? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. So we're hoping that we get, going through synthetic division, we can actually put ourselves in a situation where we find a root. Because once we break, we have ourselves a degree 4 polynomial. Once you break it down to a degree 2 polynomial, you've got your quadratic equation. So I'm going to go ahead and try the roots here. I'll try plus or minus 1 first. So doing synthetic division at a root of 1. Again, you write down the leading coefficients of your polynomial in descending order. And you go through your synthetic division here, and going through this here, I can see that I do not get a remainder of 0, so that's no good. Try it at minus 1, putting that down here. And continuing here, I get minus 1, 3, minus 3, 0, negative 20. And actually, we can see here I actually get, which is fortunate, I get a root at minus 1 here. So this polynomial will now break up into, I know I have a root at minus 1, so you're going to have an x plus 1 here. And then again, you read these coefficients down, so this becomes x cubed plus 3x squared minus 20 now equals 0. Okay, so we still can continue, right? I have not even tried these ones here. Now I checked it at 1, it was no good. I checked at minus 1, it was a root. I should actually check it again. So again, we're focusing our attention now on this lower degree polynomial, but its roots are just subsets of these roots here. So if I have a root at minus 1, it could be a double root at minus 1, so I should double check it. Do synthetic division at minus 1 here. And don't forget, when there is no variable in that spot, you put a 0. So as I go through this here and do my synthetic division, I see I do not get a remainder of 0. So there was only the single root at minus 1. So I'm going to now move on, and I'm going to try synthetic division here on a 2. So we'll go through a 2 here, and I've got 1, 3, 0, and minus 20. Checking this at 2, 10, 10, 20, and we actually do in fact get a root. So there we go. I have another root at 2. So therefore, this polynomial, putting this all together, we've got our x plus 1. Now I know that this polynomial here breaks up into the root at 2 And then we have our quadratic here, x squared plus 5x plus 10. Okay, and I know that's equal to 0. So lastly, we just check the roots here. We've got 2 of the roots. I just got to find this last 2 roots here. So this will be x is -5 plus or minus the square root of b squared, which would be 25, minus 4, a is 1, and c is 10 over 2 times a. So I end up getting here -5 plus or minus the root of -15 over 2. So this actually ends up generating complex roots. Let's put this all together. So putting this all together here, we have roots at -1, a root at 2, and then we have roots at -5 plus or minus the square root of, this will end up being 15i over 2. So this degree 4 equation, degree 4 polynomial that we ended up with has 4 roots, 2 real and 2 complex. All right, let's take a look at another problem here. We've got given to us, I have x squared minus 2 over x equaling 5. And what we want to find here is x minus 1 over x. What does that equal? So first thing you want to do here with this is we're going to go ahead and take that first equation. I'm going to multiply across by x, in which case I get x cubed minus 2 equaling 5x. Bring that to one side, you get x cubed minus 5x minus 2 equaling 0. Now I'm looking to find x minus 1 over x. Let's just figure out what we can find from this quadratic itself. Again, looking at the rational root test, what do I know? I know that if this has a rational root, it's either going to be plus or minus 1 or plus or minus 2. If you try this at -2, you end up getting here, let's check this out. I believe I get a root here. We do get a root here. So checking this out at -2, I end up getting a root at -2. So I know in this example here, this quadratic, let's kind of go over here, is going to break up into x minus 2 times x squared minus 2x minus 1 equaling, in this case, 0. Now, this question, they want us to find the value of x minus 1 over x. So if you look at this expression, we can manipulate this a bit. If I assume x is non-zero, which we can do that already, the initial equation, if you remember here, was dividing by x, so implicitly we're assuming x is non-zero. So that means I can divide across by x on this equation. So if I go ahead and divide across by x and kind of do that inside of this, I'm going to end up getting x minus 2 minus 1 over x is 0. Which means x minus 2 times x minus 1 over x minus 2 is 0, just rewriting it. Now again, if you take a look here, I have the product of 2 expressions is 0. And therefore it must be the case that either this is 0 or this is 0. Since they want me to find x minus 1 over x, it must be the case that x minus 1 over x is equal to 2. And that is our solution for this one. So again, a combination, a little bit of an algebra trick here, in combination with rational root test got us our answer. Okay, that concludes our lesson. Just using rational root test with some more creative questions. Thank you.